Hi, in this video we want to go over section 2.5, which talks about the measures of the center of the data. This time in this section we want to learn about some measures that helps us to find the center of data. If we know the center of data, we can easily talk about the type of a distribution, if it's a symmetric or skewed right or left. So we have three measures of different measures for finding the center of data, but the most important ones are mean, median, and mode. All of these measures are the values that are exactly in the center or the middle of the dataset. Let's see how we can find the mean. Mean is the average. I'm sure that everyone knows how to find the average. But we never use the word average in a statistic. So remember, instead of using the word average, we need to use the word mean. And the mean, to find the mean, we need to add all of the data values and then divide it by the number of them. And this notation is called sigma. And whenever you see this sigma, it means we need to add all of the values. Sigma x means add all of the x values. X values are the data values. So you need to add all of the data values and then divide it by the number of them. How do we show them? What's the notation for the mean? We have two notations, x bar and mu. X bar is the mean of the sample, and mu shows the mean of the population. It's very important that we remember these notations because when we move on to the next chapters, we want to use a sample statistic to find or have an estimate about the population. So we're going to use X bar to find the mean. So it's important when you read the question, you know any information that's given in the problem, is it the X bar or is it mean? If you have the mean for the sample, a group of data in population, that means it's X bar. If you have the mean of all population, that means all of the values in a data set, it's mu, which is the mean of the population. So let's have an example. To find the mean of these data values, as we said, we need to add all of these data values and divide by the number of them. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we need to add all of these 11 numbers and divide by 11. Is it 11 or? Yep. So does it matter that if we put them in order? No, it doesn't matter. We just need to add all the values, divide by the number of them. Okay? So just add them, divide by 11, and it gives us 39.1 minute, which is the mean value of this data set. And these numbers are coming from a sample, okay? Because it says the question says that the following data set includes wait times for 6 popular rides in Disneyland. So just a few numbers, not all of the numbers. Since we have only a few numbers, that means we have a sample out of the population. So that's why we show by X bar. The next measure is median. What is median? The median in a data set is the exact middle value in a data set. And to find the exact value in the middle of the data set, I only need to put all the numbers in order and find the middle one. The notation that we use for median, we can use x tilde, like this one, or we can just put an m or write med as a median, and all of them are fine. So let's see how we can find the median value. The median value, that's exactly the same as the second quartile that we talked about, that one in section 2.3. If you remember in section 2.3, when we talked about the location of data, we talked about the first, second, and third quartile. And we say if we find the second quartile, we need to put all the data values in order and then find the exact middle one. If we have odd number of data values, there is always a number in the middle. Like this example, I have 1, 2, 3, 4, 5, 6, 7, 8, 9 values. That means if I put the first 4 and the last 4 in groups, one number will be left in the middle, which is the median. But if we have even number of data values, like next example, as we have 10 numbers there, so we will have two numbers in the middle, and we need to find the average of those two numbers. We need to find the mean of those two numbers. So if I keep the first 4 and the last 4, you will see that we have two numbers left in the middle. And I need to add these two numbers and divide it by 2 to find the median. So the median of this data set is 6.5. So the median is exactly the second quartile. If I want to find the median of this data set, since we have odd number of data, we need to put the data in order first. Don't forget that part. We put them in order from least to greatest. And then since we have odd number of data values, one number will be left in the middle, which is 35. But in this case, let's see how we can find. It says find the sample median. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, this time we have 10 numbers. That's even number of data. When we have even number of data value, after putting the numbers in order from least to greatest, we know that we will be left with two numbers in the middle. Okay? So let's put the numbers in order. So the smallest number is 8. Then we have 13. We have 19, 20, 24. Oh, put 22 first. And then two 24s. 127, a 30, and a 31. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Now, after putting the numbers in order from least to greatest, I have 10 numbers. If I put in groups of 5, no number will be left. So I need to put them in groups of 4. So 1, 2, 3, 4. 1, 2, 3, 4. So I have two numbers in the middle. And I need to find the mean of these two numbers. And if I add 22 by 24 and then divide it by 2, it gives me 46 divided by 2, which is 23. So the median for this data set, which we can show by the letter M, is 23. And make sure when you are working on the problems, read the question carefully. When it says round your answer to the nearest 100, that means 2-digit after the decimal points. But in my case, in my question, there is no decimals. But if yours has, you make sure to round them correctly. Now let's see what's mode. The mode in any data set, it's the data value with the greatest frequency. Greatest frequency means the number that repeated the most. Okay, if you see two data values that they have the same frequency, they are repeating the most. If you have two data value with the same repeating, we call that data set a bimodal. Bimodal means a data set that has two modes. If we have more than two modes, we can call that data set a multimodal. But I recommend if you see more than 3, always says there is no mode. And if you see no repeating and all the numbers in the data sets are repeating the same, we has the same frequency, we say there is no mode because we can't find any number that repeat the most, more than others data. Okay, we want to find the mode in these data sets. So we need to see what numbers what number or what numbers repeating the most. Does it matter if I put them in order first? Yes, it helps you a lot if you put them in order. You can just quickly find, you can after put them in order, you can quickly find the mode. But even if you don't put them in order, you still can find the mode. So let's look at this data set. Which number is repeating the most? Yeah, you see 35, 35, 35. 35 is repeating 3 times, but no other number repeating more than 2. So the mode is 35. Or you can put them in order to make it easier, and then you will see that 35 is repeating the most, so we say the mode is 35. The next measure of center is called the mid-range. Mid-range is a data value, which is again is midway between the maximum and the minimum. Because when we put the data values in a data set in order from the least to greatest, we always have the minimum as the first number and the maximum as the last number. And the mid-range, which is the midway between min and max, that's exactly in the middle of the data set. And how we can find that? By just adding the minimum and the maximum and then divide it by 2. Let's look at this example. If I want to find the mid-range in this example, I only need to know which number is the minimum, which number is the maximum. You can put the numbers in order if it helps you, or you just find the min and max from by just looking at the data set. And you see that the 75 is the maximum number that we have here. 20 is the minimum number. So to find the mid-range, we add 75 and 20 and then divide it by 2, which is 47.5. 47.5 is the mid-range of this data set. So when do we say a statistic is resistant? A statistic means any information that we have about the sample, like the mean of the sample, or the mode of the sample, or the median of the sample, or the mid-range of the sample. Which one of these statistics are resistant? Resistant means if they have some extreme values. Extreme values means like outliers, okay? Very large or very small number. Those numbers cannot affect, the mean or the median or the mid-range. Okay, if we have outliers in a data set, those numbers do not affect that statistic. So for mean, to find the mean, you need to add all of the data values and then divide by the number. Since you're adding all the numbers, if you have one extreme value, very small or very large number, you should add all the numbers with that number as well. So it affects the mean, because by adding with a very small value or dividing by or very large value, definitely the mean change. Since the mean change, so we say the mean is not resistant. What about the median? Is median resistant? For finding the median, we need to put the numbers in order from the least to greatest. And we know that the median is the number that's exactly in the middle of the data set. Okay, if I have some extreme values, very small or very large number, definitely they go at the end or at the beginning of the data set. So do they change the median? Not necessarily. So that's why we say the median is resistant, because it's exactly in the middle and it may not change by having a small or large number in the data set. Okay? The mode, for mode, we also can say that the mode is resistant because a small number or a very big number may not change the mode, because mode only look at the data that has the most frequency. And the mid-range is not resistant as well. Because to find the mid-range, we need to add the minimum and the maximum and then divide it by 2. So if you have an extreme value, for sure your minimum or the maximum will change. That extreme value would be your min or max. And when you add it and divide it by 2, definitely change the mid-range. Okay, so the mid-range also is not resistant. Now let's see, after learning about how to find the mean, median, and mode of any data set, how we can find the mean of a frequency distribution. When we have a frequency distribution, that means we have some values, we have some classes, and we have a frequency for each class or for each data. For finding the mean, we said we need to add all the numbers and divide by the number of them. But if we have frequencies, how we can add the numbers? Because when we have frequencies, it means that number is repeating. If one number has a frequency of 5, that means I have 5 of them. And if I'm supposed to add all the numbers together, I need to add all those 5 numbers. So that's why to find the mean, we always multiply each data, each x, by its frequency first. Then we add them together and then divided by the number of them, which the number of them, or n, is the sum of all frequencies. So let's look at an example. I have a frequency table, and these frequency tables are the scores on the 5-point quiz, and we want to find the mean, median, and mode. Okay, to find the mean for x bar, I need to add all the numbers. These are the numbers, the x values, and these are the frequencies. I'm supposed to add numbers, number 5, 4, 3, 2, 1, and 0, if they only repeated once. But since I have frequency, that means they are repeating more than one. So that means 5 is repeating 7 times, 4 is repeating 15 times, 3 is repeating 13 times. So if I'm supposed to add all the numbers, if I want to show just that I'm adding all the numbers, I need to write 5 7 times. 5 plus 5 plus 5 plus 5, 4 plus 4 plus 4. I have to write 4 15 times. I have to write 3 13 times. It may take a long time. So that's why instead of adding the numbers that many times, we multiply each number by its frequency. Okay, so we need to multiply 5 by 7, multiply 4 by 15, multiply 3 by 13, multiply 2 by 7, 1 by 4, and 0 by 2. And after multiplying each number by its frequency, then we add them together. Now I need to divide it by the number of all of the data in the data set. How many data do we have in data set? I cannot say that I only have 6 numbers from 0 to 5 because each number is repeating many times. So how many numbers do we have? The number of them is based on the sum of all frequencies. I need to add all these frequencies. What is 7 plus 15 plus 13 plus 7 plus 4 plus 2? So if we add all these frequencies, let's see what do we get. 7 plus 15 is 22 plus 13 plus 7 plus 4 plus 2, which is 48. So I have 48 numbers. I need to divide by 48 to find the mean. Okay, now let's multiply those numbers. 5 times 7 is 35. 4 times 15 is 60. 3 times 13 is 39. 2 times 7 is 14. 1 times 4 is 4. And 0 times 2 is 0. And add these numbers together, divide by 48. And if I add these numbers, 35 plus 60 plus 39 plus 14 plus 4, it's 152. And if I divide it by 48, it gives me 3.17. That's the mean. Okay? Now we can find the median. To find the median, I need to put all the numbers in order from least to greatest and find the middle number in a data set. Okay. If I want to put the numbers in order, I need to start with 0. And the frequency for 0 is 2. That means I need to put 2 zeros, 4 ones, 7 twos, and I have to list all of the 48 numbers. I have to write 13 threes, 15 fours, and 7 fives. And I know I have 48 numbers, right? 48 is even number. When I have even number, that means for finding the mean, 2 numbers will be left in the middle. If you divide the whole data set in two groups of 24, no number will be left. So you need to divide in 2 groups of 23 number, 23 number. Now you will have 2 numbers in the middle, okay? Which is the data value number 24 and number 25 when you list them all. So now, instead of just listing all the numbers, you can start adding the frequencies, but you need to start from the bottom because the 0 is the smallest number. So 2 plus 4, which is 6. 6 plus 7, which is 13. 13 plus 13 is 26. Okay, that tells me the data value number 24 and 25, both of them are 3. That's right. So to find the mean, I have 2 numbers in the middle, which is 3 and 3, and then divided by 2, which gives me 3. That is the median. To find the mode, I only need to look at which number has the highest frequency, the most frequency. The numbers are from 0, 1, 2, 3, and 4, and 5. Which of these numbers have the most frequency? That's 4, because it has the greatest frequency and it's 15. So the mode is 4. So mode is 4, the median is 3, and the mean is 3.17. They have 3 different values for mean, median, and mode. Let's look at this example. In this example, we see that we have a frequency table, but this frequency table, it's with the classes of data. Instead of one data, we have classes of data. Okay, we said to find the mean, I need to multiply each data value by its frequency. But if I have classes, that means I have a range of data from 0 to 14. What data I need to choose to multiply by its frequency? Whenever you have classes and you only need one number that represents that class, you always choose midpoint. To find the midpoint, you need to add the lower class limit and the upper class limit and then divide it by 2. If you add 0 plus 14 and then divide it by 2, it gives you 14 divided by 2, which is 7. You need to add 15 by 29 divided by 2, which is 22. After finding the midpoints, these are your x value. You have the frequency. Now you need to multiply all the x values and the frequencies and then add them together, divide by the sum of the frequency. So it tells you that the mean must be 34.6 minutes in this distribution. Okay, so remember, the point of this table is that whenever you have classes means a range, an interval of data values, an interval from 0 to 14, and you only need one number, Okay, for that class to multiply by the frequency and find the mean, you need to choose the midpoint. You need to find the midpoint. Let's look at this example. We have a study on the effect that playing video games has on memory recall. As a part of this study, she collected this data: the hours that teenagers spend on video games and the number of teenagers based on the hours that they spend. Okay, we have classes, we have the frequency. These are the classes, and these are the frequency. And if you want to find the mean, you know, to find the mean, you need to multiply each data by the frequency first, and then add them together, right? Okay, I have classes, but I only need one data from each class to multiply by the frequency. So what do? I find the midpoint first. Find the midpoint, we just need to add the lower class limit and the upper class limit and then divide it by 2. If I add 0 plus 3.5 and then divide it by 2, it gives me 1.7. For the next class, I need to add 3.5 by 7.5 and then divide it by 2. So 3.5 plus 7.5 and then divided by 2, which is 5.5. Next class, 7.5 plus 11.5 divided by 2, which is, so let's see, 7.5 plus 11.5 divided by 2, 9.5. Next one is 11.5 plus 15.5 divided by 2, which is 13.5. 15.5 plus 19.5 divided by 2, which is 17. And now these are my x values. If I want to find the mean, I need to multiply each of these values by their frequency. So to find the mean, I need to multiply each of the midpoints with 1.575 by the frequency, which is 3. I need to multiply 5.5 by its frequency, which is 7. I need to multiply 9.5 by its frequency, which is 12. And then add them together. And I need to multiply 13.5 by 7. And I need to multiply 17.5 by 9. And after adding all these values, we need to divide them by the number of data in this data set. And we know that the n, or the number of data, is always equal to the sum of all frequencies. If you add all these frequencies, what do we get? What is 3 plus 7 plus 12 plus 7 plus 9? Is 38. I need to divide by 38. Okay, let's see what do we get for the mean. 1.75 times 3 is 5.25. 5.5 times 7, which is 38.5. 9.5 times 12, which is 1/14. 13.5 times 7, which is 94.5. And the last one, which is 17.5 times 9, and that's 157.5. And all of them must be added together, divided by 38. Let's add them together. So it's 409.75. If I divide it by 38, it gives me 10.78. Okay, that is the mean of this frequency. Sometimes instead of having a frequency table, we have tables which each data has its own weight. If we show the weight is similar to the frequency. And to find the mean, we do the same, exactly the same. So for the frequency, we say we need to multiply each data by its frequency. This time we also say we need to multiply each data by its weight, and then add them together, divide by the total number of data that we have in dataset. For example, if you look at this example, it says a student took 5 courses. Her final grade along the number of credits for each courses were A, which was for a 3-credit class, A for a 4-credit class, B for a 3-credit class, C for a 3-credit class, and F for 1-credit class. So the student has, and put them in table, has 5 classes. So it received A, okay, the grade, and the units for that class. For a 3-credit class, A for a 4-credit class, B for a 3-credit class, C for a 3-credit class, and F for 1-credit class. And we know in grading system, whenever you receive A, that means you receive 4 points. A is equal to 4. B is equal to 3. C is equal to 2. D equal to 1. And F equal to 0. Now, if I want to find the mean of these or the GPA of these students, the grades are my X values, the data values, and the number of units for that class is the weight for that class. It's like a frequency for that class. To find the mean, I need to multiply each grade by its weight or its frequency. Okay, we need to multiply this now. Multiply 4 by 3. Multiply 4 by 4. Multiply 3 by 3. Multiply 2 by 3. And multiply 0 by 1. And then add them together and divide by the number of what? The sum of the frequency, the sum of the weights, then which means sum of the frequency or the sum of the weights, it's the total units that that student had on that semester, which is 3 plus 4 plus 3 plus 3 plus 1, and that's 10, 30, 14. So we need to divide it by 14. Okay, so if you want to find your GPA at the end of the semester, just remember that. This is how we find GPAs. We're not going to add all of the grades that we receive and then divide it by the number of them, because each class has its own weight. So this class is a 4-unit class. So the Math 11 is a 4-unit class. So it's really important that you know, if you receive a good grade for this class, that grade will be multiplied by 4 because it's a 4-unit class, and it really changes your GPA. Okay, so 4 times 3 is 12, 4 times 4 is 16, 3 times 3 is 9, 6, and 0, and all divided by 14. Which is 43 divided by 14, and the GPA is 3.07. Okay, so remember, weight is like a frequency. Okay? Okay. Okay. That is all in section 2.5. Section 2.6 is also talking about the skewness and the mean, median, and mode, which is related to the location of the data. Okay, the center of the data, actually. So we said that one way to describe any variable is just looking at the shape of its distribution. Okay, when we collect data, it's really important that we create a shape for that distribution for the data set that we have, and based on the number that we get for mean, median, and mode, we can find the shape of a distribution. We have different types of distribution. If you see in your data set, all numbers are repeating the same. They're all repeating once or two times. They have the same frequency. Will have a uniform distribution. So uniform distribution is usually like a rectangle because all of the numbers have the same frequency. The height of each bar should be the same or almost the same. But if you create a histogram and you see that most of the values, the tallest bar, it's in the center, and the frequencies on the tails off, the frequencies tails off to the left and to the right. So we have less frequency on the tails, and then we go up. We have the most frequency in the center, and again, the frequencies decrease when we go to the right on the tail. In this case, usually the mean, median, and modes are the same. And we say we have a bell-shaped distribution. And bell-shaped distribution, which we also call it a normal distribution, is really important in a statistic, especially after chapter 5 or 6. We mostly work with the normal distributions, which are all bell-shaped distribution. So remember, in any bell-shaped distribution, mean, median, and modes are same values. Okay? If you have a distribution, you don't know if it's a bell shape, just find mean, median, and mode. If you get the same answer for all those three, that means you have a bell-shaped distribution. But sometimes the distribution shows us that we don't have a symmetric distribution, and tails to the right is longer than tails into the left. In these cases, we say we have a skewed right distribution or positively skewed distribution. Okay, so the tails on the right is longer. We have a skewed right distribution. And in this case, usually the mode is less than the median, and median is also less than the mean. So that means we have the greatest number for mean. But if you see the tails on the left is longer than the tails on the right, we have a skewed left distribution, or we say that distribution is negatively skewed distribution. And in this case, usually the mean is less than the median, and median is less than the mode. So we have the greatest number for mode in this case. Okay? Because mode is the highest bar over there in the center. So we need to know, we need to be familiar with all these 4 types of distribution. It's really important for the future chapters. Bell shape or the symmetric distribution, skewed right or skewed left distribution, which they are not symmetric. And as I said, whenever we have a bell-shaped distribution, we call it a normal distribution. And we will talk about normal distribution more on chapter 6. Let's look at an example. It says, describe the shape of this distribution. You have a histogram because the bars are touching each other. So, and you want to see what type of, what's the shape of distribution. So, let's see. Okay. I see that the tails on the left is longer than the tails on the right, which means we have a skewed left distribution. Yes. What about this question? We have a data set, and it says which one is the greatest, mean, mode, or median? And based on those three, what's the type of distribution? So we need to find those three, mean, median, and mode. So to find the median, we know that we have to put data in order, which as I see the datas are in order, okay? And then the median is the number that's exactly in the middle. So let's see how many data value do we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, we have even numbers of data. Even numbers of data means two numbers must left in the middle. So let's see. If I put the first 5 and the last 5 in groups, two numbers will be left in the middle, and I need to find the mean of these two, which is 12 plus 13 divided by 2 is 12.5. So the median is 12.5. To find the mode, I only need to look which data value is repeating the most. So in this data set, I see that 12 is repeating the most, so the mode is 12 because it's repeating 4 times. And to find the mean, I need to add all the numbers and then divide it by 12, which gives me 15.1. Now, based on the mean, median, and mode, what decision do we make? When mean is the largest one, so, or we can say when the mode is the smallest one, mode is the tallest part of the distribution, something like that. But if the mode is here, that means the median and modes are on the right side because they are greater than mode. So we have a longer tail on the right. That's right. It means that's a skewed right distribution because the mode is less than median, and median is also less than mean. So that's a skewed right distribution.